Now I'd like to introduce Eran Ofir. He's CEO of Somatix, and he wants to talk about their healthcare models. Are we okay, Rich, with volume?
I turned it up a little too high.
Okay, thank you.
Eran?
Hi, everyone. So my name is Eran. I'm the CEO and co-founder of Somatix. And my presentation will be a little bit different because what I thought of doing is to take you, meaning, I will get to the technical things, all the way to the classifiers that we use and stuff like that. But before that, I would like to start, go through the entire cycle. I hope that I won't bore you. Kind of starting with the why, and after talking about why are we doing it? Meaning, why do we need to use, AI and machine learning in healthcare? And then talk about the product. And then after talking about the product, we'll get to the technical and so on. So kind of taking you through the entire journey that we had with many challenges in the last few years. All right, so let's start with the why. Healthcare. So if you are not familiar with it, healthcare is currently the largest industry in the US. Nearly 20%, 19 point something percent of US GDP is healthcare. One of every $5 in the US is being spent on healthcare. And in fact, within a decade, it will be one of each $4, of every $4. So, if you are thinking of where to invest your money, it's probably in healthcare. And we see all the big companies, the Amazons, the Googles, the Apples, right? All of them are running towards healthcare, and for a reason. Now, even the telecoms, right? We are in the AT&T building. Let's see what's happening with the communication service providers. All of them, globally, from Australia to Europe to US. Telecom is in many cases a commodity now. So they're looking for value-added services. And value-added services is in many cases healthcare, because you have a huge subscriber base, user base, and you would like to provide them additional services while they're at home, while they're on the move, and so on. So we see many companies, communication service providers, opening up healthcare divisions in order to provide value-added services, more in Europe, Swisscom, BT, Deutsche Telekom. I think that I didn't include here Comcast and others in the US are also operating it. And they are all getting now into digital health. So maybe let's start with understanding what is digital health. Why are they all into digital health suddenly, telecom companies? So digital health is the intersection between IoT, big data, wearables, and machine learning and AI. That's why we are here today, right? And everyone are talking about integrated digital healthcare. What is integrated digital healthcare? It means that you can provide various services as a communication service provider to your users when they are at home or on the move. And this is where Somatix, this is our domain. This is what we do. We do remote patient monitoring using wearable devices, standard, commercial, regular wearable devices. We developed a technology in which we take the raw data from sensors, regular existing sensors that exist on any type of smartwatch and wristband, almost any type. And we understand from the raw data of the sensors in real time what is the movement that you do, what is the gesture, whether you are drinking, hot or cold, or eating, or taking medication, or falling, or brushing your teeth, shaving, and so on. Why? because we would like to understand continuously about a person what's called the ADLs, the activities of daily living, what that person is doing, when, where, how long, how often, why, and all that stuff. Because from there, we go into, and this is where we'll get to soon, to insights and predictive analytics. Think about elderly care. Think about remote patient monitoring of discharged patients. Think about smoking cessation programs, many different use cases, and all of them, the common denominator for all of them is the ability to provide remote patient monitoring. Now, even the government is pushing for that, the US government, because now there are CMS codes. It's called reimbursement codes, remote counseling reimbursement codes, CPT codes in healthcare, where when you provide such services as a clinic, as a provider, you receive money from the government, from Medicare and from other insurance programs, because the idea is to enable larger portions of the population with access to healthcare. And this could be done with telemedicine. So this is why remote patient monitoring. So as I explained, there are many different gestures that we can monitor. By the way, there is no big brother here, right? It's all HIPAA compliance, meaning I can't monitor what you do without you providing me your explicit consent. That's one, when I connect to your wearable device. And then even after that, when our customer, the enterprise customer, AT&T, would like to access the data to know what is it that you were doing throughout the day, then the user needs to provide his consent again. So it's all HIPAA compliant. It's device agnostic. I don't care which device it is, meaning through the operating system, whether it's iOS, Android, Tizen of Samsung, I get not to the processed API kind of data that they provide the devices, but really to the X, Y, Z of the sensors in order to understand in real time the three-dimensional vectors of the movement of the hand in space, and understanding with the mathematical models that we have developed, what is it that you do? Why? Because the holy grail of healthcare, if you'll ask any physician, is to ability to provide immediate intervention based on the context of what a person is doing. When you have that ability, it means that you can provide much better care. Think about AT&T, for instance. If someone is falling at home, an elderly person, you know it in real time, right? And you can connect that person or alert the family member or connect that person with the emergency services. We do wandering. Basically, we analyze ourselves with machine learning algorithms, location, we do geofencing, where is home, work, commuting patterns, point of interest. So we see a woman in New York, elderly woman, and it's 8 p.m. and she's 10 miles away from home or from her regular commuting patterns. Think about dementia. So again, we alert someone that there might be a situation. We see discharged patients at home that are not moving enough or did not drink the entire day. There might be a situation. So we alert the caregiver. It could be AT&T, if it's a service provider by AT&T, or it could be Mount Sinai. We work with Mount Sinai, for instance, in the city. And why? Because we would like to prevent that person from being readmitted to the hospital. Because when he's being readmitted, it's extra cost for the entire system, not only for the person, but also for the hospital, because they have readmission fine if that person is readmitted back to the hospital within 30 days from the time when he was discharged. So there are many, now just for you to give you like a flavor of how much data we are talking about, we are currently capturing, modeling, and analyzing 500,000 data records per person per day that we analyze and correlate continuously in order to understand the connections. What connections am I talking about? So what's the connection between your physical movement, the activities that you do, to your emotional status? By the way, how do I know your emotional status? I know because, for instance, your communication on social media, that's one. Two, with some of these devices, they have galvanic skin response and skin temperature. So it's the same two sensors, by the way, that are being used in polygraphs. So I can measure emotional status, arousal, stress, and stuff like that. I know your location, so I know the temperature. I can do geofencing, so I see that it's Friday afternoon and you're going with your buddies to that neighborhood bar that you go to smoke and to drink, right? So on your way there, I would like to do some kind of stuff, behavioral stuff, in order to prevent you from smoking and drinking at that neighborhood bar, and so on. So even I even correlate activities that you have on your calendar with your, for instance, I see that every time that you meet with your manager at work, afterwards you're going downstairs and to the corner of the building and you smoke 2 cigarettes. So next time that my servers see that you have this meeting coming up today at 12 noon, we send you in the morning messages telling you why won't you put nicotine patch, eat an apple, do meditation, whatever will prevent you those 2 cigarettes. It's called CBT, cognitive behavioral therapy. So it's all patented. We work, it's all, again, in healthcare, you have to go through clinical validation. So with the assistance from NIH, from NIDA, from National Science Institute, from many different, we get funding for grants, we get grants for clinical validation of all of that stuff, because no hospital or anyone will choose it without me showing them the evidence of the efficacy that we bring. Now, so let's go one level below. Let's start talking about machine learning and AI. So where do we use machine learning? Let's start there. So we use machine learning in gesture detection, again, in real time. And you can see that I differentiated between complex gesture detection, smoking, drinking, eating, medication intaking, and stuff like that, and between easy activities like falling and sleeping and stuff like that. So we need different classifiers, and I will get to it when we use machine learnings for simple gestures like walking, or for complicated gestures like eating or drinking. By the way, I can even differentiate between hot drink and cold drink. Think about it. The way that you capture a coffee versus Coke and the speed that you serve it to your mouth and the length of the sip is different between cold drink and hot drink. And if I know that you are in a bar, then I know now that you are drinking now in that bar, and using the galvanic skin response that provides me the diffusion of the alcohol through the skin, I also know that you had alcohol. Now, think about 2 years from now, we're already talking with car manufacturers in the era of connected car. You gave your son the car keys, and your smart band knows that you're intoxicated, so the car won't ignite, for instance. By the way, we know if you try to give it to someone else. We developed a whole set of patents because we know if it's on which hand it is, and basically if you turned it off, if you gave it to someone else, and stuff like that. So you can't fool the system. We have done it for health insurance companies because they're all now into dynamic pricing, basically, of health insurance programs. Dynamic level detection. We measure, again, there are different, we measure the accelerometer, but not just steps. We measure the accelerometer because we are trying to understand the variance, the gait, and stuff like that in order for us to do stuff like what's the probability for a person, for an elderly person, for falling. So again, we are trying to create predictive analytics with respect to the well-being of elderlies, for instance. We are doing all kinds of activity levels, statistical tests to measure the activity level of a person. Why? Because we would like to provide the hospital with, it's like a clinical decision support system, right? That's what we do. We provide them with the analysis, machine learning based, whether there was a deterioration in the health condition of that person that was released a week ago from the hospital, or wasn't an improvement. So what should the hospital do with respect to it? Should they do something proactively about that patient or do nothing? Now, it's all using CBT, cognitive behavioral therapy, and ACT, acceptance and commitment therapy. We work with professors in many different universities, as you've seen, and we took methodologies of psychology treatment, and we translated them into machine learning algorithms. So basically, we apply psychology through technology. For instance, I'll give you an example. We apply in the messages that are being sent to the mobile phones, we apply 4 different types of messages. SURF, it's called. We trademark it. SURF is social, emotional, rational, and financial. I provide you flavored messages, text messages, that are flavored, social, emotional, rational, and financial. I measure over time, over a month, the response of that person to the different type of messages that you were given. And once I have those responses, I build a psychological profile for you in our cloud-based servers. Now that I have the psychological profile of that person, his sensitivity to messages that are social, emotional, rational, financial, I start playing with the dosages of manipulating, right? I start playing with the dosages of the messages that I provide in order to obtain a higher efficacy of the treatment. Think about smoking cessation treatment. Think about, we work with Cincinnati children on measuring snacking of obese adolescents. So the clinicians can provide them remote counseling about their eating habits. Think about eating disorders and stuff like that. So basically, we use technology in order to apply psychology, right? That's basically how machine learning is being used here. Let's go deeper. So in our internal jargon at the company, we use machine learning, but AI is being used for when we're talking about insights, because when we need to do like holistic assessment of a patient, of an individual, and we need to find insights and predictive analytics, then we really start using the AI. So for instance, we do multidimensional clustering in order to try and analyze or predict when that person will have his next cigarette. Why is it important? Because then we can do what's called in psychology harm reduction. Because, for instance, if I measure, you will be surprised to know that the biggest correlation with respect to how many cigarettes a person will have throughout the day is how much time. That's the number 1 predictor. How long was it before how long was it before the wake-up time of that person and his first cigarette? If you'll correlate, you'll see that this indicator is the best predictor for how many cigarettes a person will have throughout the day. So that's like one example. And how you discover it? Again, obviously, through AI. We identify when a change in patterns becomes a trend. So are we successful with the CBT, with the psychological process, or aren't we? We detect with linear classifiers basically when a user is trying to gamify the system, because we are working with health insurance companies, and as you know, most of the health insurance companies now in the US are giving perks to users based on how they behave, how much you walk, how much you sleep, how much you stand, and so on. Like most of them do this by now. So it's called dynamic pricing. But the problem that users are fooling health insurance companies, it's called gamification. And you have channels on YouTube where you see dogs in Central Parks walk with their Fitbits. Yeah, you can see there are channels for it. Or you see people putting their smartwatch on these ceiling fans in order to count steps, or on power drills, so it will count all kinds of stuff. So basically, people are trying to fool the system. So basically, there are classifiers that we use in order to discover when is it that people are trying to gamify the system. So this is how it looks like. Basically, we provide dashboards with the analysis of how much a person smoked today and for the week, and what was the change, and where, and when, and all that stuff. This is very interesting because here you can see where machine learning is being deployed. So it's a clinic, and that clinic is using six different types of smoking cessation treatments. Currently, they are blind. They are applying these treatments randomly to their patient space, and they don't know what's the success rate. We provide them basically analysis, comparative analysis, showing them what were the most successful programs for their patient base in the last 7 weeks in reducing smoking. So that's basically an example of how this is being used. This is for elderly. You can see that we measure like their, you can pick and choose what is it that you would like to see. But the nurses can see now how much they walk, if they woke up, right? In some cases they don't. How much they drink throughout the day, if they take their medication, because there are like 450 different medication trackers in the market, but the problem with all of them is that none of them is providing the last mile, right? None of them is telling the clinician whether the person actually took the medication. And this is something that we provide as well. Now, let's get to the how. That's where it starts getting interesting. So basically, the platform was built with Java and Spring. It was all deployed on Amazon Web Services. You can see the different classes that we used for computing, for storage. It's all MySQL databases with, basic almost user management in terms of Cognito and stuff like that. In terms of the business logic, maybe instead of talking about the business logic that way, we'll show the platform architecture. So you can see the different tools that we used. Again, you need to understand one challenge is that it needs to be in real time or near real time, right? Because it's healthcare. It doesn't help that I will know it the day after. I need the ability to provide immediate intervention based on the context of what a person is doing. Let's keep it in mind. So that's one thing. The other thing is the number of permutation, right? I said 500,000 data records per person per day that you need to keep store and correlate all the time to all the previous days in order to find the insights and the predictive analytics. So there is a lot of data there. And then basically, so that's kind of a very high level with respect to events that are running between the backend and the different recipients. The recipients could be the admin, the nurse at the control center, the user, because the users have, in some cases, not in all cases, in some cases, apps that where they get notifications, and the dashboard. Or it could be family members and stuff like that. So there are many different recipients, and we need to differentiate between the different recipients and what they are allowed to receive. Now, challenges. So one challenge was that, again, remember, we are talking about wearable devices. So we're talking about devices that are running on low power, low CPU, and low memory. And you need, with that device, to do all that computing in real time, because the gesture detection is being done on the wearable device itself. Otherwise, it can't be done in real time. So we had big problem with memory, big problems with the memory, because we found that it's a challenge to, because of the number of parameters that we need to use, we had problems with the ROM memory. The system architecture is pretty complex, and we had to use to develop our own like proprietary C implementations that took us almost a year to develop in order to be capable of running super efficient code where every byte means a lot on devices which such slow, that are such that have scarce resources. Now, in terms of wearable devices, it's still, you know, kind of, or at least it was in the last 3 years, early days, right? So like smartphones 15 years ago. So the operating systems are still crashing all the time of Android Wear as well of Apple Watches. The specs doesn't match what the devices are really doing. So in terms of sampling rate, in terms of power, in terms of all that stuff, the APIs behave different than what you received from the documentation of the operating system. So we had to think about it, of the amount of the cleansing, data cleansing that we need to do, because we need to take the sensors and we need to take out all the noise, and we need to bring all of them. Each sensor is being sampled in a different rate, so we need to bring all of them to a common denominator, and you have problems whether the sensors are within range or outside of range. So we need to store the data and transmit it in batches in order not to lose data and stuff like that. So that took a long time. Power consumption is obviously a big problem. It was our #1 problem at the time. For instance, I'll give you just one example. A gyroscope consumes 50 times more power than accelerometer. So you don't want to sample the gyroscope unless you have to. So you look at the accelerometer, and only after you get from the accelerometer the relevant signals or signals that are interesting, then only then you sample the gyroscope in order not to waste energy. You turn CPU off, you turn off the CPU whenever possible. You send data in batches and not continuously, because Bluetooth is very problematic with respect to energy usage. And we had to find and sometimes to develop special families of classifiers. So for us, the #1 parameter with classifier is the energy level that it consumes, because it might be not irrelevant for us. So some few tips. I want to leave a few minutes for questions. So there are no shortcuts. For instance, at the beginning we thought about creating the same, using the same code for iOS and Android. Doesn't work. When you do that level of work, you have to go all the way and develop with the different operating systems. Outsourcing never worked for us. Unfortunately, we've tried 4, 5, 6 times, and outside developers never managed to handle that level of complexity. So at the end, we ended with everything being done at our core team. The developers are based in Israel, and everything that is market-facing, product management, project management, marketing, and so on, myself, it's here in New York. We had many debates, aggressive debates about the architectures. We found, in the hard way, that fancy architectures and all these, all that new stuff and stuff like that, in many cases it failed us because it wasn't robust enough, it wasn't scalable enough, and this is why, like, we moved back to MySQL and stuff like that, that is much more stable. So this is it. I just wanted kind of to provide you with a real-life example of how you use machine learning and AI in order to build something that is being used every day with patients in the US. Questions? Right. So this is why I mentioned that we are not, it's not a big brother approach. It's meant for people, you know, we are dealing with discharged patients, we are dealing with elderlies, we are dealing with chronic patients, with diabetic patients, with disabled people. So it's people who are looking for, you know, who are, they want the help, right? They're under a treatment, they're under monitoring and stuff like that. So they need to place the device, whether it's a smartband or smartwatch, on the dominant hand, because like you do over 90% of your activities with your dominant hand. This is why, by the way, in some cases, with elderlies, it's easy, because in any case, all you provide them is like with a smartband. Most of them don't wear anyhow, like Apple Watches and stuff like that. With people that are getting, like we work with Mount Sinai and with 24 the Health System and with Penn Medicine, on smoking cessation programs. So there basically they ask the patients to place the devices on the dominant hand, meaning on the hand with which they smoke. So it's not that I'm measuring someone without his willingness or participation. Yeah. Yes, it's adaptive. Yeah. Yes, that's a very good point. So yes, the algorithms are adaptive. Basically, it's different between one person to, so in the background, every week, without you knowing, we download to your smartphone, you know, an algorithm that is a little bit different based on your gestures and stuff like that, because we measure a lot of what we call features that are specific because as you can imagine, with age, with a health situation, with even with respect to the length of your arm, the movements will look different from one person to another. So every week, without you knowing, we download over the air algorithms that, so we start, basically I have graphs, not here, we start with something like 85% detection rate, and we get within less than a month to nearly 100%. In fact, we published few articles in peer-reviewed journals where the researchers presented like 100% accuracy detection. Excuse me? I'm not sure that I know to. Okay, okay, okay. So again, we have done that at the beginning when we started the development. We used to video a person doing all kinds of stuff, and that's how we developed the mathematical models, basically, that represent the different gestures. But now with the machine learning algorithms that we use, we don't need it because we know how those gestures looks like. I should say that the problem is that for every gesture there are many different permutations. So for instance, even smoking, it looks completely different on MATLAB when a person is standing, sitting, driving, walking, climbing stairs. It looks just completely different. This is why, by the way, you can't store all the data in the cloud and do the computing of the gesture in the cloud, because you don't have enough bandwidth to take all the data from the device to the cloud and compare it to so many permutations for every gesture. It all has to be done in C on the device itself. That's the problem. Now, in some cases, we do in the first week like false positive and false negative. So the user is getting messages about the gesture, and he needs to confirm that it's a gesture. And then basically after 1 week we know if like we are 100%. It depends on the situation. Thank you.